Hi, let's cover 3.2. It's taking me a while to get this out to y'all. Life happens, right? So please make sure that you've gone through and read the section for 3.2. There are really good how-tos on how to do it. In fact, in every chapter, there's really good how to do some things. I might provide you the formula and the logic behind it, and I try to give you what I think about when I'm doing the problem, but they might say something different that makes more sense to you. And if that's the case, use what works, okay? So let's see if I can get over, there we go. So finding the domain of a function as a set of ordered pairs. Well, in 3.1, we were talking about how your domain is made up of from a relation, from a set of ordered pairs. It's made up of the independent values, or the X values. So if we're finding the domain of given ordered pairs from this set, it's just the X values. So we're going to create a set, and that set's going to include in the X value 2, the 10 is in the Y value. So we'll come over here to 3, 4, 5, and 6, and then finish off the set. That's it for that one. Find the domain of the given function. So when you're looking at any type of problem like this, the first thing I ask myself is, what can I and what can I not plug into X? Is there anything that I could plug into X to where it's going to make this function imaginary or undefined? And looking at this, I mean, you can even graph this if you want to. It's going to be, you can plug in any number you want to in this one. I know this is not a great XY, but for your X's, that's what we're looking at. And this function here is it's just a parabola going up. All right. Sorry, it's not a pretty parabola like it should be. I have not been drinking. But it comes down here to 1 and it just goes up. All right. And so there's nothing hindering it from choosing any point along the X-axis to be utilized. So for this one, I'm going to say that the domain is negative infinity to positive infinity. Okay, that's my domain. All numbers, all real numbers. All right, so finding the domain of this function. Now this one is limited, because what can you not have in the denominator of a fraction? You can't have a 0. A 0 in the denominator will make this function undefined. So I need to know what number cannot be placed in the denominator. In order to do that, I just take my denominator and set it equal to 0. So anytime you have a fraction and you need to find the domain, you just take the denominator, set it equal to 0, and find out what you can't have in your domain. So 2 minus x equal to 0. I'm just going to move my x to the other side, and I get that 2 is equal to x. So I cannot have 2 equaling to x in this function, because if I do, the whole thing's going to be undefined. So I'm going to include in my domain from negative infinity all the way up to 2, but not including it. Or you can have from 2, again, not included because there's no bracket, up to positive infinity. And that's the only thing that's hindering this fraction. All right, finding the domain of the function f of x is equal to square root of 7 minus x. So with this one, what you're going to want to do is, what's going to make this radical imaginary? Well, that means the number underneath the radical would be negative, because then you would have an I. So we don't want that. So we need to find out where 7 minus x needs to be what? Greater than or equal to 0. That's what has to be underneath there. So what's underneath that radical has to be greater than or equal to 0 in order to be positive, okay, or 0. You can take the square root of 0, it's just 0. So I'm just going to solve for x here. I'm going to add x to both sides. So this just means that x, I'm going to rewrite it for me, x, I like to read it left to right, x is less than or equal to 7. It's the same thing. I just moved my x over and just reconfigured. Okay, so can I have anything less than, what if I had 7x less than or equal to 7? If I plug in a 7, I'm good. If I plug in an 8, I'm not good. So that's why x is not included in the 8s. So what does this look like on my number chart? We've got 7, we've got 0, 7's included, all right, and x is less than, so it's everything this way. So from negative infinity to 7, and 7 is included, so it gets a bracket, okay? And that's what you're going to want to do for your radicals, that's a square root. Describing sets on the real number line. Describe the intervals of values shown using inequality notation, set builder notation, and interval notation. Okay, so inequality notation is just going to be, for the first one, it's 1 less than or equal to x less than or equal to 3. It's equal to because it has the dots. For the set builder notation, it's just the same thing, but you're going to put it in a set. X is what we're utilizing, and then we're going to rewrite 1 less than or equal to x less than or equal to 3. And then the bottom one is going to be interval notation. 1 is included and 3 is included. All right, so that takes care of the 1 to 3. Let's talk about the 5 and up. So greater than, not equal to 5. So x is greater than 5. That's what's representing that one. For this other one, what you might want to do is erase this little set here and have a u with, or you could just do x and then x greater than 5. And then the last one is 5 is not included in the interval notation, and it goes to positive infinity. And I would put a u there. Okay. Finding domain and range of graphs. So I received an email today from a student who thought she was looking for the domain, but they were asking for the range. So domain is always read from left to right, from smallest to largest. Okay. So for this domain, you're going to want to have, I know it might, is that going to even work for me? Let's see if I can write. Nope, can't do that. Hold on. Sorry about that. Okay, so for the domain, it starts at -5. It's only going to, domain's only going to be utilizing the x-axis, and -5 is included, and then it keeps going to infinity, to a positive infinity. So I would have a bracket 5, comma, infinity, parenthesis for my domain. My range is from bottom to top. So my range, this cute little blue line is going to keep going on and on and on forever. So I'm only looking at my y-axis at this point. So I'm going to start with a parenthesis, negative infinity. And as I'm coming up the graph, I have to see where does it stop. And it stops at +5, and +5 is included. So it's going to be parenthesis, negative infinity, comma, 5, bracket. And that is going to be your range for this one. Remember, domains is going to look at your x-axis, what's the expanse across the graph, and then your range is going to look at the vertical. So it's going to look at your y-axis, bottom to top. All right. Finding domain and range from a graph, find the domain and range of this function. Okay, so domain is, we're going to strictly look at our x-axis going from left to right. The first number I see is -3, but it's got a circle because it's not included. All right. So my domain, hopefully I can write, nope, I still can't write here. hold on, let me see if there's a, this thing is so particular. Pen, I wonder if that's what happened. Blue. Oh, there we go. Now I can write on it. No wonder. I must hit the highlighter for some reason. So my domain is going to be parenthesis because -3 is not included. And how far over to the right does this graph go? It goes all the way over to the 1 right here. Notice it, and 1 is included. So -3 is not included, and it goes over to 1 that is. So 1 gets a bracket. Okay. My range is going from bottom to top. So how low is this graph? Well, the lowest point looks to be -4. All right, so -4, and it's included. And how tall, how high does this graph go? Well, it only goes to the x-axis, so it goes to 0. So remember, we're getting our points from the y-axis. Over here at -3, it's not touching, but it's touching right here. So I'm going to give that sucker a bracket. If this other point was not here, then it would not. It would be a 0 with a parenthesis. But because it's touching, it gets to get a bracket. And that's the range. Alaska crude oil production. Find the domain and range. So the domain we're going to look at along the dates at the bottom to receive our domain. And gosh, this is hard. It was hard in class too. I don't remember what numbers we chose in class. I look at it this way. I'm like 75, 76, 77, 78, 79. So I probably have 2 points here. So I'm going to go from 1973, including, all the way over to, it looks like a 10, to 2010, including. And this is my domain. My range, I have to look along the 1,000 barrels per day range. And it starts, doesn't matter where it starts. What matters is how low is this sucker. So where is this hitting? I think we said about 175 in class. So 170, 175, including. And then it goes how high? It's going above the 2,000 mark. So 2020, I don't know, 2010, 2005. It's so tight, and it's not broken into where we can see it. So I'm going to go with 2010 and including. All right. Find the domain and range using the toolkit function. So on the next slide, I provided you an actual visual of the toolkit function to help you see what we're dealing with. So here's the toolkit function of what this would look like. And the toolkit that it's representing is f of x is equal to x3. So this is just your cubic graph. All right, it's just x cubed represented. That's not what we have here, but we can still utilize this information to help us see, okay, what would our domain and range be given this toolkit function? Well, the domain, you're not going to have any limitations on what you can plug into x. All right. You're going to get anywhere from -infinity to positive infinity. This graph goes on and on and on. All right. The other thing is top to bottom or bottom to top, there's no limitations there either to where this graph is going to be cut off or veered away from any number of any specificity. So I would say for the domain and range for this, and I'm going to show you the actual graph itself. The one on the left is your toolkit function, f of x is equal to x cubed. The one on the right is the representation of the function we're dealing with here. And there's no difference other than it's had some shifting and a little bit of shrinkage on that one, a little condensing. So for the domain on this and the range, domain and range, I'm going to say both, from -infinity to positive infinity. All right, finding the domain and range on this one. So again, this is a fraction. So we're going to take that fraction, take the denominator, set it equal to 0. Well, what can we have? Yeah, it just can't equal 0. So x plus 1 equal to 0. So x equals -1. So x cannot equal -1 for the domain. All right, so my domain is going to be from -infinity to -1, or it's going to be from -1 to +infinity. There's my domain. My range is what numbers will I get back? So what's going to be represented here on my graph? Well, can we ever have 0? Anytime you have a fraction like this to where it has a constant in the numerator, so just a number, no variable, your range cannot equal 0, ever, okay? Because -1 is the only number that you can't plug into this, 0 is the only thing you'll never get out, okay? And you can, I don't know if I drew this graph on this next one. Let me see if I drew a graph on here. Oh yeah, I provided it. So let's look at the range again, because this fraction will never be 0, the range will be the same. And I'll show you when we go to this next slide here. The range is going to be from -infinity to 0, or from 0 to +infinity. Okay, it will never touch the x-axis. It can't, right? Simply because it has only a constant in the numerator. Let's look at the next one. Find the domain or range of f of x is equal to 2 square root of x plus 4. Well, the same thing with this one. We can't have a negative in our radical, so we need to find out what we cannot plug in to that radical. I'm not even taking into consideration the 2 because it's not doing anything negative to where it's going to affect this. That what's underneath that radical does, though. So x plus 4 has to be what? Greater than or equal to 0. It can't be less than 0 because that would be imaginary. So I'm just solving for x. Sensitive little thing. I'm subtracting 4 from both sides. And I get -4. So that tells me my domain is from -infinity. No, x is greater than or equal to -4. So it's equal to, it's got to have a bracket, -4 and greater than -4. Remember, infinity always gets parentheses. Okay, so there's my domain. What is my range going to look like here? Will I ever have a negative number that comes out of that? No, I won't, because 2 is already positive, and underneath my radical, I'll never have anything that's going to provide me a negative number. So there will be no negative numbers in my answer. Can I get 0 as an answer? I can if I plug in -4 for x, because -4 plus 4 is going to give me 0. Square root of 0 is 0, times 2 is 0. So my answers are going to be from 0 for my range. It's going to be including 0 to +infinity. Okay, let's look at the graph. So we've got there's our -4, there's our domain. It goes from -4 and greater. And then our range, notice it's on the x-axis. So it's from 0, including 0, and then all the way to +infinity. Good stuff. All right, piecewise functions. I know y'all were really struggling on this. If you are still struggling after the quiz and everything this week, please get with me or a tutor. I don't want you to walk into an exam still struggling with piecewise functions, and you're going to have to do this in pre-calc. So please get comfortable with it. Let's do it now before you get there, because they're not as nice as I am. Just saying. All right. So piecewise function, they're going to provide you different formulas and then specific domains that go along with those. Let's just look into some examples. That's going to probably be the easiest. And this isn't a really good example for it. But this one's something really good that you're going to want to use going forward. So it says a cell phone company uses the function below to determine the cost, C, in dollars for G gigabyte data transfers. So it says find the cost using 1.5 gigabytes of data and the cost of using 4 gigabytes of data. Well, you have to understand before even looking at those two things, what's represented above. Well, right now it's got the C of G, which is the cost based on gigabytes, is $25 if you use between 0 and 2 gigabytes, not including 2. Once you reach that 2 gigabyte usage, you're going to have to come down here and you're going to pay that $25 plus $10 times however many gigabytes you're using minus 2. Okay. So that tells me something there. If you're using 2 gigabytes, 2 minus 2 is 0. So if you're actually using 2 gigabytes, you're only going to pay $25. Do you see that? Because if you plug in 2 for G, 2 minus 2 is 0, times 10 is 0, plus 25 is 25. So you're actually going to pay $25 straight only for using 2 gigabytes as well. All right. So it says find the cost of using 1.5 gigabytes. So 1.5 is right in here between my 0 and 2. So the cost of using 1.5 gigabytes is $25. All right. That was easy enough. The second one, they're using 4 gigabytes. So we're going to have to go to the second formula for that one. So the cost of using 4 gigabytes is 25 plus 10 times 4 minus 2. We're strictly using that one, not the one above. So how much is that? 25 plus 10 times 2 is 25 plus 20, $45. So the cost of using 4 gigabytes is $45. All right, here's the other piece that I think you're struggling more with this than anything. Let's graph this. So no, this is not the one. What does this look like? 25. So we have to go up to 25. So how can I do this? I could do 5, 10, 15, 20, 25. So there's 25. It's 25 between 0 and 2. We'll use these as 1, 2, 3, 4, 5, 6, 8, 9, 10. And we'll use these as 5, 10, 15, 20, 25. We can make them whatever we want, right? Just be consistent. So from 0 to 2, and 2 is not included, it's $25. So there's that piece. And not included here either. Then we've got with G greater than or equal to 2, how is that going to look? Well, it's going to be 25 plus 10 to, that's going to be a hard one to graph. Let's see what that looks like on Desmos. Hold on a second. Maybe I can show y'all. Oh, wrong there. Y equals 25 plus 10 times x minus 2. There we go. Easy enough. All right, I'm going to show this to you. I'm going to show you what this one looks like. And we're only looking for greater than the 2 here. So we're going to have to go up here past the 25. There we go. Right here is the 25 and the 2. So this sucker is just going up linearly. Doesn't surprise you, right? Because 10G, it would be 10x. So that would be, it would be going up by 10 from 25. So let's push that sucker up, and it is including. So for this piece, it's in, darn it, it did it again. hold on, y'all. And okay, is including, and it is, I don't know if I'm going to be able to get it up that high. Let's go this way. There we go. So there's my piecewise function as probably as good as I'm going to get it drawn right now. Okay, good. We're going to graph another one. This one will be a much better draw. It says graphing a piecewise function, sketch a graph of the function. So we need a parabola, an x square, it's quadratic, for x less than or equal to 1. Then we're going to have to draw a line, y equals 3, between 1, not including, and 2, including. And then we're going to have to draw another line, y equals x, for x is greater than 2. I've got graph paper. All right, so I'm going to start with my first one. My first one is just a parabola. So if I were to look at my toolkit function, you would see it's just one of these guys right here. It's just a parabola, okay? So, but this one is from x less than or equal to 1. So where is 1? 1 is 1, but it's including. All right, then 2, oh no, it's got to be less. Oh, less than 1. X is less than 1. So here. Gosh darn you. Okay, so there's my first point. And then it's going to come down to 0. It's a curve. Go with the fact that this is a curve. And it's going to keep going as a parabola. I cannot draw on this thing. All right, then the other one, and that's where it stops. Okay, so it has a dot here, then it goes off to be a parabola. There's nothing to the right on the first piece. The second piece is y equals 3, which is a horizontal line at 3. So 1, 2, 3, but it's only from 1 to 2. So if this is 1 and this is 2, 1's not included, but 2 is. So it's just that. And then the third one is y equals x, which is just a straight line that goes from 0, 0, 1, 1, 2, 2, 3, 3. So it's going to start at x is greater than 2, so but 2 is not included. And then it's going to just keep going straight through these because it's greater than. See if I can connect these and get a decent line for y'all. Okay. There we go. All right, so we've got all three. That is a piecewise function. You have to be able to graph that going into pre-calc. If you struggle with it, get back in that math and use those problems for practice to get you where you need to be and feel comfortable. All right. Oh, that's it for 3.2. All right. Let me know if you have any questions.